There are three types of yields that can be determined from a chemical reaction. The theoretical yield is the maximum amount of product that could be formed. This is a calculation. The actual yield is the amount of product that actually forms when this is carried out in a laboratory situation, so you will be given the actual yield. And then the percent yield is a ratio of the actual to the theoretical yield expressed as a percent. So let's look at how we get some of these yields. First problem here, we have 84.8 grams of iron 3 oxide. We have excess carbon monoxide. What is the theoretical yield of iron? We want that in grams. Theoretical yield is simply a calculation. So we have 84.8 grams starting Fe2O3. And if I want to go from grams of Fe2O3 to grams of iron, first off I need to go from grams back to moles. So I need the molar mass of Fe2O3, and from the periodic table the molar mass is 159.6. Then we're going to do my mole to mole ratio. We're going to go from Fe2O3 to what I want to solve for, which is iron. Mole to mole ratio, go back to your balanced chemical equation. That is 2 moles of iron to 1 mole of Fe2O3. We want to go ahead and go to grams, so when we're in moles, we need the molar mass of iron, and the molar mass of iron, 55.8. So this is the theoretical yield. It's nothing new to us because we've been doing mass-to-mass problems before. Theoretical yield is simply a calculation. So the theoretical yield, the maximum amount of iron that I could get, is 59.3 grams. Percent yield. If 75 grams of FeCO3 is heated with an excess of oxygen, 45 grams of ferric oxide is produced. Anytime you get a number on the product side like the 45, that is your actual yield. So this number right here is the actual. I want to know the percent yield of this reaction. So what I'm going to do is start with 75 grams of the FeCO3, and I'm going to solve for grams of the Fe2O3. So we're going to go from grams back to moles. So I need the molar mass of FeCO3, which is 115.8. Then we're going to do our mole to mole ratio. There are 4 moles of the FeCO3 for every 2 moles of the Fe2O3. Once I'm in moles, I want to go ahead and go to grams. So I need the molar mass of Fe2O3 in 1 mole. There are 159.6 grams. This is the theoretical yield of Fe2O3. So the theoretical yield when I perform the calculation is 51.7 grams. Now this is the maximum. This is the maximum amount, the theoretical yield, 51.7 grams. I want to know the percent yield. The percent yield is taking the actual number, which is 45. You're always given the actual. So 45 divided by the max, which is 51.7, times 100. So the theoretical yield in this problem, 87%. You can never get over 100% yield. All right, so let's kind of put all these together in one more problem. We have 15 grams of nitrogen reacting with 15 grams of hydrogen, and ammonia is produced. What is the percent yield? The first thing you need is a balanced chemical equation. So we have nitrogen, which is diatomic, plus hydrogen, which is diatomic, forming NH3. That has to be balanced before we start. Okay, we have 15 grams of both reactants. So what we have to do is set up 2 separate equations. We have 15 grams of nitrogen and 15 grams of hydrogen. So we'll start with the nitrogen. we want to solve for the theoretical yield of NH3. So we're going to take the 15 grams of nitrogen. We're in grams, we need to go to moles. 28 grams per mole. Once we get moles of nitrogen, we need the mole ratio. So it's 1 mole of N2 for every 2 moles NH3. And I want the grams of NH3, so in 1 mole, the molar mass of NH3 is 17 grams. Okay, so if I start with 15 grams of nitrogen and I do the math, I would get 18.2 grams of NH3. Okay, but I also have 15 grams of hydrogen, so I need to start with the 15 grams of H2 and do a very similar problem. We're going to take grams, go back to moles. Hydrogen is just 2 grams per mole. Then we're going to do the mole to mole ratio, and there are 3 moles of H2 for every 2 moles of NH3. And the last step, the molar mass of NH3, 17 grams per mole. Okay, so I had 15 grams of both reactants. I need to figure out the limiting reagent. This would produce 85 grams of NH3. So we always choose the smaller number. So we're going to cross off the 85, excess hydrogen. The nitrogen is the limiting reagent, and this is how much 15 grams of nitrogen would produce. So this is my theoretical yield. I always pick the smaller number for the theoretical yield. I want to know the percent yield. Well, the percent yield is taking the actual yield, which again, the actual yield is given in the problem, 10.5 grams. And I know that's the actual yield because it's the number that's given for the product. So that's the actual 10.5 divided by the theoretical, 18.2, times 100. And percent yields have to be less than 100%. They will always be less than 100. 57.7% is the percent yield for this particular reaction.